All right, so we're looking at isotopic notation. That's when you have a symbol right here and you have numbers around it. So if I didn't have this 15, which was the atomic number, which was the number of protons. Okay, if I didn't have that, I could still find out how many protons. Okay, because if I didn't have any of this and I just had the mass number and the symbol, I could look on the periodic table and it could tell me how many protons. Because the one number that's good to go that you should use on the periodic table is the atomic number, which is the whole number on the periodic table. So on the squares on the periodic table, so let's put a P up here. Let's do phosphorus. So E square is for its own element, right? So you would have the name phosphorus, the symbol, and you would have a whole number. That whole number is the atomic number. Whoop, and it's not 9. It's not 9. It should be 15. I've lost my mind. Oh, lost my mind. There we go. 15. Should be 15. This is the atomic number. Okay, atomic number. It is also the number of protons. Okay, so if I didn't have this little number here, I could go find it on the periodic table. That's why we can take it off sometimes, and you can still find it. So we know from the period, from having a P here, we know how many protons. Okay, from the periodic table. Now, on the periodic table, there's also another number. That other number. Let me make this 42. That other number is always a decimal. Always have a decimal. Now, the mistake some people made on the test is that they thought this is the mass number. It is not the mass number. Do not use that for the mass number. That will lead you astray every time. Okay, look, the mass number that I gave you over here is 35. That's not the 30.9. Okay, this 30.9 is the atomic weight. That is the average of all the isotopes of this element. And an isotope is where you have the same amount of protons. So you have several atoms of the same element, same amount of protons, but they would have different amounts of neutrons. So let's say that we had P30. We had an atom of that. And we had a P31. And we had an atom of that. And we had P34. And we had an atom of that. Those are all isotopes. Isotopes vary in the number. They have different numbers of neutrons. Same amount of protons. All of these have a proton of 15. Okay? But they have different amounts of neutrons. And since they have different amount of neutrons, that means some of them are heavier than others. Okay? So if some are heavier than others, when I want the weight of the average, then I just have to average those together. So let's say I had a bunch of people on a scale. And I got some fat people, and I got some skinny people, and I got some middle-sized people. Okay? If I got a weight from all those people being on a scale, and I got the average, would that be the weight of any one of those people? No, it wouldn't. It wouldn't be the weight of the skinny person. It wouldn't be the weight of the fat person. And it might be closer to the weight of the kind of middle person, but it's going to be an average. And so on the periodic table, that number with a decimal is the average. It is not the mass number. So when we look at isotopes, We are looking at an individual atom. And that individual atom has a certain number of neutrons. And so we're only looking at one. We're not looking at an average. So we might give you this on the test and then ask you what the atomic number is. And we know that from the periodic table was 15. So if the atomic number is 15, do we know the number of protons? Yes, we do, because the atomic number and the proton number, those are the same. Same. Number of protons gives us the atomic number. So that's the same number. Okay? So I make big things here. All right, so if we know the proton number is 15, then can we find the number of neutrons? Yes, we can. We can take 35, the mass number, and subtract 15. So we have a total of 20 neutrons because mass number is protons plus neutrons. So if I take the mass number and I subtract protons, I get the neutrons. Okay, and then we just got to look at the electron number. Number of electrons. Well, that's when we have to not look at the mass number. Mass number's got nothing to do with ions. So when we look at the number of electrons, we're looking at the number of, we're deciding whether it's an ion or not. Let me just make this better. Here we go. So we know number of protons is 15, and we want number of electrons. Well, in this case, we are looking at if there is anything right here. Is there any number there? Is there any sign there? Because there could be either. If there is nothing in this space right here, that means we have a neutral atom. And we're getting to Erica's question here in just a second about ions. If we have a neutral atom, that means there's nothing right there in this space when we write isotopic notation. That means the proton and electron number are the same. Oh, I shouldn't have made so many. Okay, let's say this is 15. 15 positive charges. Let's see, 3, 6, 9, 12. I need 3 more. All right, 15 positive charges. Protons are positive. Protons, positive. Okay, that means there's 15 positive charges. Well, if I have electrons, I have 15 negative charges. 3, 6, 9, 10, 11, 12, 13, 14, 15. All right. So if I have 15 positive charges and 15 negative charges, they would all cancel themselves out. Right? 15 positive, 15 negatives cancel each other out. 0 net charge. 0. That's why we don't put anything there. But if we have an ion, so let's talk about when we have an ion, which really was Erica's question. We're finally getting to Erica's question here. There will be a symbol here and maybe a number. So this is phosphorus. Phosphorus will form this ion right there. So when you have something over here in this spot, it's an ion. Okay? That means that the electrons do not equal the protons. So Erica was asking me, how do we form ions? Okay, this is a mistake that a lot of people make. This is not what Erica made, but a lot of people made this mistake. they change the number of protons to get to this number, to get an ion. That is not what happens. We never, ever, 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 slap your hand. Don't do it. Never change the number of protons to make an ion. The only thing you do to make an ion is change the number of electrons. So let me make this look a little better. There we go. So we have 15 positive charges. I should make these smaller so I can get 15 on here. Oh, we'll say that's 2. 3, 6, 9, 12, 15. Oh, no, I think I have 16. Since I've made that 2. Okay, let's.
I have a quick notation question. So on your ionic notation with the 3 negative sign, or would it matter which side of the 3 the negative sign's on?
That is a really good question, and it does not matter. You can see this in different books that they'll put it like this or like the other. It doesn't matter. I see it both ways all the time. So it doesn't matter. I like to put it where it's 3 negatives saying, because I, in my mind, think, oh, it's 3 negative charges, not a negative 3. So that's why I put it after, but it doesn't really matter. So that's a good question. All right. So what this 3 is saying is that there are 3 extra charges, 3 extra negative charges. So we know we have 15 plus charges. And if we had 15 negative charges, they would cancel each other out and we'd have 0. We'd have a neutral atom. But that's not what we have. We have an ion. And in an ion, the only thing that changes are the electrons. We can have less electrons than the protons. We can have more electrons than the protons. Okay? So if we have a negative 3 charge, that means we have 3 extra negative charges. We have 3 more extra electrons than we have protons. So in this atom, the proton number was 15. We know it was 15 because it's phosphorus. If it was any other number, we would have a different element. That's why you cannot change the proton number when you form an ion, because you would change the element. So what changes is the electron number. So what had the phosphorus is over on the right-hand side of the periodic table where all the nonmetals are. And what nonmetals do is they gain electrons. They like to pull them away. They have a lot of electronegativity where they can pull electrons away. So what happens is we have 3 extra. So we have 18 electrons because we have 3 more than the protons. Is there any question about that? Because I'm about to quiz you. Does anybody not understand something about that? All right. I'm going to give you an example then, and you're going to tell me. All right. Let's find a different element. Something maybe doesn't have so many. All right. How about lithium? We're going to have lithium with a mass number of 8 and a charge of 1 plus. So now in your mind, this is what I want you all to do. I want you to tell me what the mass number is. And I want you to tell me what the proton number is. I want you to tell me how many electrons and how many neutrons, just for good luck, just for good measure. So on a piece of paper, work this out, and I'm going to be asking you about this because this is something you have to do on the test, and this is something people are struggling with. And y'all are just smart to be in here to ask me. A lot more people should be in here asking me about this stuff. I'm going to give you time to work, and then I'm going to answer. Yep, good job, Ethan. All right, so the mass number we know is 8, because this is always where the mass number is. Okay? Now, we would have to look on the periodic table. We have to look on the periodic table to find out what the proton number is. So that's 3. So 3. So we know it's 3. So can we find out how many neutrons then? Yes, we can. Neutron number will be 5. That's 8 minus 3, right? So we take the protons plus the neutrons, and that gives us the mass number. Okay, so because protons and neutrons are the biggest particles in the atom, and they're the ones that make up all the mass. Because the electron is so small, we don't really even count it towards the mass because it's so small. It's like having a feather in an elephant. I'm going to count if I put a feather in the elephant, I'm not going to get the weight of the feather. It's going to be mostly the weight of the elephant. That's the way it is. The electron is the feather, where the protons and neutrons are the elephants. They're most of the mass, and so we say that that's what the mass is of the element. So now we just got to look at the electron. We know the electron is a different number than 3 because of that charge right there. So what does this mean, 1 plus charge? Well, I know I have 3 protons because I have to have 3 because it's lithium. Well, if I have 3 protons, but my charge is plus 1, that means I have 1 extra positive charge. So how many electrons does that make? Well, if I have to have 1 extra, that only leaves me with 2 electrons. Okay, so that is how an ion is formed. It just changes the number of the electron. It's either going to be more than the protons or less than the protons. Okay, any of you have a question about that?
I have a question.
All right, Miss G's been paying attention.
So, obviously, this is not my subject, but I want clarification again, because I know if I have a question, you guys are having the same issue.
Yep.
So on the mass number of 8, would you explain again how it differs from the periodic? Atomic weight? Is that atomic weight and mass weight for the isotope? What's the difference there?
All right, so let me show a periodic table. That might be helpful. Let me find one. I have to find one.
Now that's confusing to me. And I accept that as fact, and I'd work with it from there. But I could see it causing confusion if you're working on your own, trying to figure it out.
It does, and I do not like the way that Buzz explained it at all, because I would have never explained it that way. And it's part of the problem why when we got to test also. All right, so you see the periodic table here. So on the whiteboard that I just gave you, I said lithium was 8, right? The math I just had y'all do is 8. Do you see 8 right there? Oh, lithium's right here. Okay. Do you see 8 anywhere? No, because 8 is the mass number of, that's like us seeing 10 atoms of lithium, and we pick one of them out. I pick one of them out, and it's one of the big fat lithiums. It weighs more than some of the others, and that's the difference in isotopes. Some of them weigh more than others. So Some of them have a higher amount of neutrons, and some of them have a lower amount of neutrons, and a lot of them probably have 7 or mass number of 7, so that means 4 neutrons. So it's an average of all the atoms of lithium that we could have in a certain sample. So if we had 10 atoms of lithium, some of them, most of them would be weigh around 7, but some would weigh 10 and some would weigh 5. But that decimal on the periodic table is an average, and never, ever, never, ever, ever use it as a mass number. Mass number is the amount of particles, and you can't have 0.9 of a particle, right? We're going to count the particles, and we can't have 0.9. So never, ever, ever use the decimal from the periodic table as the mass number, because that's not what it is. That's an average of all the masses of an atom's isotopes. So that's a really good question, one that people get wrong all the time. All the time. Okay, did y'all have a question on the ions? How do you get the charges?